Hello and welcome to Home Science Lessons of Mr. Mac. Particles, Lesson 5, Calculating Internal Energy. So please remember to turn your phone off or put it away out of the way so that you've got other windows on your computer that are open that might distract you. Make sure that you've got your full attention on the lesson and try and do it all in one go. Right, whenever you're ready then, let's go for it. You can do this. So the lesson design, same as always, bit of retrieval on previous topics, bit of teacher instruction for me under the camera. Today we're going to look at the energy equation involving mass and specific latent heat. Then we're going to do some couple of worked examples and then drill is thrill to embed the knowledge, and then you have a chance to practice later. Don't forget at any point during the video, if you need to pause it, please do so, and then write your notes. This shouldn't be a passive process. All right, so the very first thing I'm going to look at actually is from last lesson. These are the slop shed loads of practice questions. So there's question 1. So if you've done this already, we're going to reveal the answer in just a sec. If you haven't done this, probably a good time to pause and have a go from last lesson. So that's the first slide. Pause and have a go. Second slide, again, this is from last lesson. So if you haven't already, pause and have a go. Third slide, same yet again, pause and have a go. Right, here are the answers. So there's the answers for the first slide. And there are the answers for the second and third slide. So back onto today's lesson. Our first retrieval slide is about metals and non-metals. So pause, get your pen, paper out, or your pencil, and have a go now, please. And there's the answer to slide 1. So that comes up quite a lot, that metallic structure comes up in bonding, comes up in electricity, comes up in metals. So make sure you know it and jot down any notes on things that you got wrong. Next slide is on acids and alkalis. So strong and weak acids and the neutralization equation, and what type of salts are made from different acids, 3 laboratory acids. And if you've ever been in my class, you'll know that we do a chant to help us remember that. Pause, have a go. And here are the answers. And the chant, just so you know for another time: nitric acid makes a nitrate salt. Hydrochloric acid makes a chloride salt. Sulfuric acid makes a sulfate salt. And chanting those may help you to remember it and may help you pronounce the words as well. Third slide is on the current particle topic, and this is a bit of a recap on what we did last lesson. So direct retrieval from last time. Pause and have a go. All right, there's our answers, and those are the answers which are going to help us today, because we're going to be using specific latent heat in our equations when we do our modeling under the camera in just a moment. So the amount of energy required to change the state of 1 kilogram of a substance with no change in temperature. So if we know the specific latent heat and we know the mass of the substance that we're trying to change state, then we can work out the energy required to do it. That brings us nicely onto today's new knowledge. So we're going to be looking at the equation for calculating energy in a change of state, otherwise known as internal energy. And we're also going to be doing a couple of worked examples. So here we go then. Let's get on with this. So if you've seen my lessons in the past, always like to write the equation first. And I think we'll write the equation in full at the top of the page for this one. So let's get that all lined up. So energy measured in joules. And that we can have a letter E to stand for energy is equal to mass measured in kilograms multiplied by specific latent heat. And that is measured in joules per kilogram. So we could sum that little equation up in E equals ml. Right, so we've seen the equation. At this point, you might want to drill in the equation and make sure you know it. Now we're going to have a go at a couple of worked examples. So worked example number 1, the specific latent heat for boiling is 2,260,000 joules per kilogram. How much energy is needed to completely boil 1.5 kilos of water at 100 degrees C? So that would be 1.5 liters, actually, interestingly enough. And you'd be staggered how much energy is needed to do that. So don't be overfilling your kettle when you make a cup of tea. Think of all that wasted energy. So E equals ml. There's the equation. We want to know what E is in this case, and we know the mass, and we know the specific latent heat. So this is a very simple example. 2,260,000 joules per kilo multiplied by the mass of 1.5 kilograms equals A. And as always, use your calculator. No guessing here, guys. No guessing at all. 2,260,000. So there we've got our 2,260,000 multiplied by 1.5 equals 339,000. So 339,000. So we've got 3,390,000 joules. Wow, that's a lot of energy to boil 1.5 kilos of water or get it to 100 degrees C. So that's our first example. Let's have a look at our second example. So if you wish to pause and freeze that and have a look and make your notes, now probably be a good time. Otherwise, let's move on to example 2. The specific latent heat of fusion for a particular substance is 120 is 120,000 or 120,000 joules per kilogram. We write our equation. So L is 120,000 joules per kilogram. The mass is 250 grams. And we need to times those to find out energy in joules, but it's not quite as straightforward as that, because grams, those aren't the units used in our equation. Remember, it's joules, kilograms, and joules per kilogram. So we need to convert that. So grams into kilograms, you need to divide by 1,000. So 250 divided by 1,000 gives us 0.25. So 0.25 times 120,000, that's our specific latent heat of fusion, will tell us how much energy is required. So 0.25 times 120,000 equals 30,000 joules. And we can actually convert that into something, another unit called kilojoules. If we divide that by 1,000, that would give us 30 kJ or kilojoules. That just means 30,000 joules. So there's our little bit of working out for today, our equation, and in a moment you're going to have a go at some examples yourselves. So have your calculator ready to have a go and practice. And before you have a go and practice, embed the knowledge. Drill, drill, drill. Drill is thrill. So what do we need to do to embed that knowledge? We need to cover up our work and write down what we can remember. Really, it'd be the equation and the units involved in the equation. And then once we covered it up, write down what we can remember and then check it to see if we've got it right. So look, cover, write, check. Or if you're lucky enough to have someone at home with you, hand your notes over to them and get them to ask you a few questions on it. So next, we're on the SLOP task 5, which is an example to practice some of the use of the equation that you've just seen. So some of the examples in SLOP 5 are similar to the ones you've just seen, and some of them are a little bit more challenging, where you might have to rearrange the equation. So either you can print this off, show my homework before the lesson, or you may want to just have a go, pause the video and have a go from the slide now. There we go, there's the first 2 questions. And look, how nice am I? The equation is given to you. Pause, have a go, if you haven't already. And then I've got some more questions for you, and those ones are slightly more challenging. You may have to rearrange them. And I will show you the working out and how to do those next lesson. And you can get your answers checked next lesson as well. So pause and have a go. So next lesson is going to be about particle model and pressure in gases. So explaining what happens in gases in terms of particles and the effect that has on pressure. So can't wait till next time. In the meantime, complete the SLOP task that you've been given with this video or attached with this homework. Do a little bit of retrieval practice on today's new learning and also the learning that you've done this week. Keep it fresh in the memory. And if there's anyone not getting in the act with this, share the video with them. So all that remains now is for me to say thank you for working hard and paying attention to this video, making your notes. Thank you for working hard on your retrieval practice. Thank you for working hard with a SLOP task. So see you soon. Goodbye.